In the next section of chapter 6.3, we're going to talk about, we're going to discuss about the normal probability, which means that the distribution that we are going to discuss from now on, especially for chapter 6, is mainly the normal distribution. Just so that you kind of recall a bit of what a normal distribution is. It's basically a distribution whose shape looks like the shape of a bell. It looks like this. Okay, and that's called the normal distribution. And if you have forgotten, then I do advise you to look over the video on section 6.2, which shows you the relationship between the area under the curve and the probability. And you also need to know how to find that probability once you and the usage of a table, because this is what we use to find those probability and so on and so forth. Okay, so part of today's lesson is to be able to take advantage of the area to find the probability of a certain event happening. So in order for us to do this, we need to take a situation and convert that situation to a standard normal. What we mean by that is we're going to convert all our average to the number 0, and we're going to convert our standard deviation to 1. And that's what we mean by standardizing it. So before we get into further, let's first make a note of a few things here. Remember that the z-score can be found using a specific formula, and I'll show you what that formula is in a little bit. But before we find the z-score, we need to let x be just a variable that represents something with a mean that's given to us, and a standard deviation that's also will be given to us. All right. Then the value z can be found. Z is a number. Remember, z is a number. And z can be found by taking the x value that we're looking for minus the mean and then divide that by sigma. So in a specific problem, the author is going to give you the average. They will also give you the standard deviation, and they will ask, hey, what's the probability that x is going to happen? And in order to know that, they will also give you the x value so that you can calculate the z value. Okay, so pretty much all these values will be given to you, and then you use this formula to find the z value. From the z value, then you can find the area under the curve. By knowing the area under the curve, then that's the probability. So that's all the relationship. Okay. All right. So z, we say that z has a standard normal distribution. What does standard mean? It means that the average is 0 and the standard deviation is 1. That's what we mean by the standard, the word standard. Again, if you need to review this, look over video in section 6.2, especially paying attention to standard. Okay. This means that the mean is 0 and the standard deviation is 1. When we take the normal variable and write it as z equals to x minus the average over sigma, we are standardizing it. So we're converting it into an average of 0 and a standard deviation of 1. Okay. The value of the standardized variable tells us how many standard deviations the original variable is from the mean. All right, so our first example here is for you to be able to find the z value. All right, so let's say that there's a normal variable, and by the way, one of the big keywords that you're going to see in every problem is the word normal. By seeing the word normal, it means that they're referring to a normal distribution. Okay, so the word normal is going to come up a lot. So a normal variable has a mean. See how they give us the mean? And a standard deviation of 3. So they give us those two. And it says that find the value of z when x equals to 75. So they also give us z. Alright, so all we have to do is use this formula to find what the z-score is. So we go z equals to x minus the mean over sigma, and then we just plug it in. 75 minus 69.5 divided by 3. That comes out to be 5.5 divided by 3. 75 minus 69.5 is 5.5 divided by 3. So we use a calculator and we get 1.83. Okay, so the z value is 1.83. Okay, what does that mean? Well, if the average is 69, let's say the average height is 69.5, and someone else has a height of 75 inch, then that person is 1.3 standard deviation away from the mean. All right. Awesome. Okay.